So before, what is loop losses? So loop means it is a closed path for the flow of charge. In that loop, in that loop, here at somewhere that voltage may be appear to increase, at somewhere it may be appear to decrease. But finally, within the closed path, some of the voltages that may be increased or decreased, some of the voltages must be equal to zero. Some of the voltages must be equal to zero. So this we can call it as Kirchhoff's loop law or Kirchhoff's law of voltages or Kirchhoff's second law. Right? So we are following the rules of sign convention while traversing through the loop. Right? So maybe you are following clockwise direction or anti-clockwise direction. Anything you can follow in the loop, but you must follow the rules of sign convention in case of battery and in case of resistor. Right? Through a resistor, there is importance to the direction of current. In case of battery, no importance to the direction of current. Just we are observing the terminal. Right? If you are moving from left to right, that means a negative terminal to positive terminal, suppose positive symbol. Positive terminal to negative terminal, negative symbol. Through a resistor, along the direction of current or in the direction of current, it is taken to be negative. Opposite in the direction of current, taken to be positive. So these we will follow. So yesterday, I am written the equation for a simple electric circuit. For the simple electric circuit. For example, if you see here, if you see here, just I'm going to cover this information. So, right. So here just I covered the information what is given here. Then next, here look at, if you follow the path in this, if you follow the path in this, suppose here I started at A. I started at A. So from A, you can go in any direction. Suppose if I am trying to move in clockwise direction, I'll move towards B next, B to C, C to D, D to E, then finally reaching the point A. See here, starting and ending same. Starting point and ending point same. So I am traversing through the circuit opposite in the direction of current in the loop. Right? So here opposite through a resistor positive. In case of battery, terminal to terminal, positive terminal to negative terminal. So A to B, I have one component, right? A to B, I have one component, right? So that is what here it is battery, right? Then next B to C, B to C, B to C, nothing is there. Oh, no, sorry. I have a resistor B to C, right? Then remaining C to D or D to E or E to A, there are no components. Nothing is available. So I got two components in the loop. So what they are here, they are simply a battery and a resistor. So in case of battery, directly you are able to get voltage. But in case of a resistor, how do you find the voltage? So here we are taking product of current in that branch and the resistance of that given component product. So V equal to IR constant. So within the loop, that sum of the voltages must be zero. So I applied. Then I need to calculate the sum. So A to B, I have a component here that is potential difference, battery. Right, directly I am moving from positive terminal to negative terminal. So negative sign is applied. So V1 with negative sign through a resistor. So through a resistor, I need to apply the Ohm's law, that is product of current and the resistance. Then sign convention, opposite in the direction of current, positive. So on transposing, what will write V1 equal to I into R1. So this is I got. Suppose if I take that direction chaining, right? So A to E, E to D, D to C, C to B, and reaching finally A. I changed the direction in a anti-clockwise direction now. So what will be the equation you are able to write here? So here A to E, no component. E to D, no component. D to C, no component. C to B, there is a component that is resistor here. Then B to A, there is one more component that is battery here. So two components only. Then what about your direction now? Along the current direction. So through a resistor along the current direction, right? We will take symbols plus. Sorry, along the current direction, we will take opposite sign minus. Then through a resistor, applying the Ohm's law, product of current and the resistance IR1. The next through a battery, negative terminal to positive terminal. So that is taken as here plus V1 equal to 0. On transposing V1 equal to, I will get IR1. So did you got any difference in any direction? Traversing through a loop in any direction using the sign conventions properly, you will get the same equations. Is there any confusion to discuss? Are there any confusion? If nothing, just give me a quick impression. If you are clear about this one, yes. Right now, we'll go for the second example here. So what the second example is given, just look at that. So here simply I need to cover this one. Just a second. So I covered the solution here. Okay. So solution covered by color right here. Now the question is finding the voltage, right? Verifying the law, loop law. So for that, I need to select the path. So you may select any path. You may select any path. It may be clockwise direction or anti-clockwise direction. Suppose if I am in the clockwise direction, that is what here we will write the loop name as here clockwise direction. A to B first, then B to C, C to D, D to E, and finally reaching the point A. So this is clockwise direction. Then anti-clockwise direction. I'll write the equations in both formats, clockwise and anti-clockwise direction. So here, anti-clockwise direction, A to E, E to D, D to C, C to B, and finally reaching A. Then components, right? So where they are. So simple logic I am following here to locate them easily in between the branches or in between two locations, points, right? Suppose A to B, right? A to B, I have one component here, right? That is resistor R, right? So symbolically, I am writing as R. Then B to C, I have one more component that is resistor R. Then C to D, I have a battery. So using B here. Then D to E, I have a resistance R. Then E to A, there is one more battery. These are the components. So how many? 5 there. So totally I will get 5 terms in my equation. So what they are here? A to B. I am traversing opposite in the direction of current through a resistor. So it is given as positive symbol. No need to write positive symbol for the first term. That is product of resistance and current IR1. The next B2C opposite in the direction of current through a resistor taken to be positive sign. Then product of current and resistance IR2. Next C2D, I have a battery. Positive terminal to negative terminal I am moving. So negative sign will be assigned for the voltage, that is V1. Next D2E, through a resistor opposite in the direction taken to be positive. Then product of current and resistance IR3 it is. Next here E2A, I have a battery, then positive terminal to negative terminal, so negative sign assigned, and the voltage is V2, right? I got. So that is equal to 0. So this is the equation written in a clockwise direction. Then I'll go for anti-clockwise direction. So in the anti-clockwise direction, A to E, there is a component that is battery here. Next, E to D, there is a component resistance. D to C, battery. C to D, sorry, C to B, resistor, and B to A, resistor. There are same number of components in this direction. So 5. So A to E, battery, negative terminal to positive terminal. So plus V2. Next, E to D, through a resistor along the current direction taken to be negative, and product of current and resistance is taken IR3. Then D to C, negative terminal to positive terminal, it is positive, and the voltage is something V1. Next, C2D, resistors in the direction of current. So taken as negative, product of I and R 2. Next, through a resistor along the direction minus. So product of current and resistance IR1 is equal to 0. So observe the difference between equation 1 and equation 2 here. Are the same or different? Are the same or different? Anyone? Speak out. Are the same or different? So what to do to understand that? Here individually you can observe here. Individually you can observe. For example, here first IR1 is there. So in your equation 2 IR1 there? Yes, there. Next IR2. Yes, available. IR2. Next V1. V1 available. Next IR3. Here is IR3. Next, here is IR3. Next V2. V2 is here there. V2 also available. But the symbols are opposite. What the difference is? Components are same, but symbols are opposite. Right? Symbols are opposite. So here, simply, if the symbols are indicating you are traveled through the loop in opposite direction. So that's why symbols are got oppositely. If you transpose this equation to LHS to RHS, all the symbols of the components will be taken to be opposite. For example, here IR1 is there. IR1 opposite side will become plus. Then next IR2, left side minus, right side plus IR2. Next here V1, left side plus, right side minus. Next IR3, left side minus, right side plus IR3. Next here V2, left side plus, right side minus. Then you got the equation 1. See here. On transposing equation 2 like this, you got the same equation given in equation 1. So what we need to understand in these equations? Simply, you can traverse through the loop in any direction, but you will get the same answer. Are you clear about this one? Are you clear about this? Go to quick impression here. Yes. So you got an idea how to write the equations. How to write the equations, right? So now we are moving to the another example here, that is writing the equations only, right? So just you are selecting a loop from the available diagram, right? From the available diagram. So simple here to understand. What is that here? What is that here? Figure number 27 has only one loop. You are writing the equations in both directions. That you need to practice. Then I'll give you explanation for the example 4 only. Example 3, same as your example 2. No difference in that. Right? Following clockwise and anti-clockwise. Then here, come to example 4. Come to example 4. Here, did you see different currents available in them? In the given loops? Are there different amount of currents as there? Different currents are available. What they are, namely I1 current, I2 current, and I1 plus I2 current. So now you are able to see clear. Zoom, right? So look at them here. There are three types of currents available. There are three types of currents, but namely they are here two, I1 and I2. Not three different types, only two types. Here, one is I1 and the other is I2. So how many number of currents are there? That many number of equations are required by you to solve that. Number of equations must be equal to number of currents. So namely they are I1 and I2 only, right? Sometimes they may give you here I3 also. What is I3 actually? Here according to your junction law, at junction F, the two currents I1 and I2 are joining. Then I3 equal to, we are able to say I1 plus I2. Are you clear about this one? Using junction law, what I am saying here, in the branch HC, the amount of current is available, right? The amount of current is available is equal to sum of the remaining two currents, because they together joining at the junction, sum of the currents reaching I1, I2 equal to sum of the currents leaving. Only one current is leaving, that is taken as something I3 by me, right? So that I3 is given as what? Sum of the two currents reaching the junction, leaving or reaching, both are same. Are you clear about this one? We are using junction law in loop law. Is it clear? Go to quick impression. Yes. Rohit, no response from you. Are you there? Is it clear? Rohit. Okay. So this is, you need to observe. Then here, for two equations, I need to select two loops minimum, right? How many possible? Whatever it may be, but you need minimum two equations by selecting two different loops. So in that selection also, I will give you one logic. Select the loop with current direction same, right? Current direction same. It may be clockwise direction or anti-clockwise direction, but don't select the equation, sorry, don't select the loop with opposite currents. For example, in the given diagram, I have a loop that which has opposite directions. See here, I covered this with the rectangular box. Look at that now. Suppose the loop name is here. The loop name is here A, B, C, D, E, F, A. Look at that. Here A to C, C to D, the direction of current is same. But in the D to F branch, the current direction exactly opposite to the branch AC. So upward, it has left side direction, left side, and downward also left side. So both are opposite. Both are opposite when you reach the point F here. So this type of loops you need not to select. Don't select them. Right? So I need only two loops to solve I1 and I2. So what they are here? A, B, C, D, G, H, F, A. This is one of the loop. Then second loop I am taking only in the same direction. That is started from suppose F. I am moving towards D, G, H, F. So this is, sorry, one more point is missed. F2, E, D, G, H, F. Right? Then write the equations for them. For example, if I write for the loop 1, A to B, A to B, there is a battery. Then B to C, B to C. What I have? B to C. B to C, I have a resistance. I have a resistance. Next to C to D, nothing. Next to D to G, D to G also nothing. G to H, I have a resistor. H to F, nothing. F to A, nothing. So how many components? Three components. What they are? Battery and two resistors. Then battery, positive terminal to negative terminal. So minus V1. Next, B to C, through a resistor, opposite direction. So plus symbol, product of current in that branch I1 and resistance R1. Next, here G to H, opposite in direction, taken to be plus, and product of current and resistance. So you can take that current as I1 plus I2 and multiplied by resistance R3. That must be equal to 0. Then solving this equation, right? Solving this equation. So here, if you are solving, you are getting three currents, right? To avoid that one, what I am doing here, I am changing this as here I1 plus I2 as I3 or amount I, anything you can take. So what your equation will be written as minus V1 plus I1 R1 plus I1 plus I2 is taken as I3 R3, that equal to 0. Then go to equation number 2. Loop number 2. So what loop number 2 is? What loop number 2 is? Right here, three currents you are getting. Minimum 3 loops you need to take. Minimum 3 loops. What the 3 loops are here? Actually, this is a wrong direction current is taken. So it is not possible. In this, you can write that with the opposite directions also I suggested in your textbook. Right? Actually, here the current directions are possible here. Battery opposite connection is possible. Right? Okay, whatever it may be, you can write for equation, loop 2. So in the loop 2, F to E, opposite to, battery, right? There is a battery. Next, E to D, there is a resistance. Then D to G, there is nothing. G to H, nothing. H to F, nothing. Sorry, G to H, there is a resistor. G to H, there is a resistor, and H to F, nothing. So what the equation will be written here? The equation will be written by following the rules of sign convention here. F value is, F2E is battery. So battery negative terminal you are reaching. So minus symbol V2. Next E2D. E2D there is a resistor. So product of current in that branch I2, then resistor 2. So what will take here? Minus or plus? Plus symbol because I am moving opposite. Then through a resistor again opposite direction to the current. Then product of current and the resistance I3 R3 equal to 0. Right? You are unable to solve this equation because three different currents existing. Three different currents existing. Right? So you need to replace one of them. You need to replace one of them. How do you replace? Here I am able to replace this I2. How can I replace I2? I2 is equals to, here from this relation, I2 is equals to I1 minus, sorry, I3 minus I1. I3 minus I1. So here I3 replacing here, I3 replacing here by I2 replacing by using I3 minus I1. So your equation now changed as follow. So minus V2 plus I2 replaced by I3 minus I1 into R2 plus I3 R3 equal to 0. Then what you will get? Minus V2 plus I3 R2 minus I1 R2 plus I3 R3. So in this way also you are able to change this equation into two different currents available, I1, I3 only. So here is it possible to solve or not? Yes, possible, because you are given by values of R1, R2, R3 here. Suppose R1 given 1 ohm, R2 is given 2 ohms, R3 is given 3 ohms suppose. Then what your equation will be written as here? By the product of that respective values here. R1 is taken 1, R2 is taken 3. So 3I3 you will get here, right? And I1 R2, 2I1 you will get. So by adding, you are able to get one of the current. It may be I1 or it may be I3. So just make a screenshot here. Try to solve this by taking the different values. V1 equal to suppose 5 volts, V2 equal to 10 volts. And R1, R2, R3 values are given. I is 1, 2, 3. I is 1, 2, 3. Right? So use this same information what I am given on the screen and find out I1, I3 values and also I2 value. Right? I don't know is it possible or not, but I am thinking it is compulsory possible. Right? So have a screenshot please. Solve it. Solve it. Completed. Go to quick impression. Completed screenshot. Yes. Right? Try to solve it using the same loop law. Okay. Then I'm moving to the another here. That is example number 5. So example number 5 also writing the equations. Example number 5 also writing the equations. I think no difference in this. Is there any difference? Both are same, I think. Example 4 and example 5. Example 4, example 5, both are same. Right? No need to go for that. So now we are coming to the example number 6 here. Example number 6 here. So just you need this information. Okay, then solve this one. Right. So now I'll try to solve this. Right. So join using the same link in the next. Right. So thank you.